There's one more method for solving quadratic equations that we're going to look at, and it's called solution by completing the square. Okay. So we've got some examples on page 82. If we just take the first one, we've got f of x. Now, don't worry about this, but it just means that it's a changing function, so that it means that there are different values for x, but we know that already. F of x is equal to x squared plus 6x. If we complete the square, it looks like this. Because then it would be a square, and then because the original equation is without the 9, we have to subtract the 9. And the reason we do this is because this square is a very neat way to deal with a quadratic equation. So we've got this x plus 3 squared minus 9. Do you see how that's equal to that? You got the x squared, 3 by x plus 3 by x gives you the 6 plus the 9. And then we have to remember to subtract the 9. So this is the way we complete the square. We take away the last term that we added to the square to make it a square. So maybe we can look at this again a bit slower as to how we get there. We can take another example. X squared minus 12x. Okay, what can we do with x squared minus 12x? Well, it's equal to x minus 6 squared minus 36. But how do we know that it's equal to this? Well, if we add these two together, so let's just look at how this expands. X minus 6, x minus 6. X squared minus 6x minus 6x plus 36. This minus 6x gives us this negative 12x here. That's what we're looking for. That's what we need. So now we've got it. We've manipulated the numbers and we've got it. But we have to make sure that this is true, that this is equal to this. And this does not equal this. X squared minus 12x does not equal x minus 6 squared. It would be nice if it did. It would be easy to solve, but it doesn't. So to make this true, we have to add this negative 36. We have to take away the 36 at the end. Let's look at another example. X squared plus 3x. So we want a term that gives us this 3x. So we've got to imagine, we know that the first term is x because it's just x squared. But we've got to imagine, what are the two numbers that when added together give me that 3x in the middle? Well, in this case, it's just half of 3. It's 1.5. And then we need to do something here to even it out. So let's look at the first part of the equation. It's not true yet. When we expand this, we get x squared plus 3 over 2x plus 3 over 2x plus 9 over 4. So then to complete the square, we just have to minus that 9 over 4 again. And then it's true. Then it does equal this. So x squared plus 3x is equal to x plus 3 over 2 squared minus 9 1/4. Oh, sorry, 9 over 4. Okay. Let's do another one. Let's do x squared minus 10x minus 17. Okay, this one is quite interesting. What two numbers are going to give me this negative 10x? Well, negative 5. So let's say x minus 5 squared. X minus 5 gives me a positive 25. So I have to subtract that 25. But I've already got a negative 17 that's there on this side. So I have to put these two numbers together. So it's equal to x minus 5 squared. 25 plus 17 is 42. So we've got minus 42. Another one. X squared plus 6x plus 1. We've got this plus 1 on this side. But it's not part of our quadratic equation. We know from up here that the x squared plus x plus 6x is equal to x plus 3, because that plus 3x gives us plus 6x. And then we have to subtract the 9, because we've got an extra 3 squared at the end that's not here. So we subtract the 9, and then we add the 1. Okay. Now you can try some of the equations in exercise 31.